cut on this computer. Okay, I started recording. So the first Newton law is like that. Okay, I'm sorry if for this particular class it's a delayed a bit because I'm still learning to do the class using two devices at the same time. Normally, I just use my laptop, which has a stylus in it, to teach for this particular class, and I got used to it. Now, because the device is still under maintenance, then I need to do another things. Oh, wait. Just use this presentation. Okay. Share. Learning about something is quite different. Okay. Share screen. Start now. Okay. Okay. I hope you can see this, right? Okay. Just now when we talk about the just now when we talk about it, right? So, okay. The first Newton law. Okay. It is supposed to be like this. Sigma F is equal to 0. Okay. Sigma F is equal to 0, which means that what we will get is this. A is equal to 0. Okay. That's the first thing that you're supposed to know. And we will use this in our statics class. Sigma F equal to 0, A is equal to 0. Okay. Because static is, there is no movement. What we will use is just the first case of this first Newton law, where there is no movement. Okay, if there is no movement, A equal to 0 means that a stationary things will be in stationary position when sigma F is equal to 0. Okay. Is this S3? Do you understand about the S3?
Yes, sir.
Okay, good. Now, my second question. What is the second Newton law?
The force of an object is proportional to that of its acceleration and mass.
Okay, yeah. Sigma F is equal to M multiplied by A. That's the second Newton law. And because we are not, we are discussing about statics in this particular class, we will not be discussing about this too much. So we will not be discussing about this too much. But we will use the third Newton law. Anyone have any idea about the third Newton law?
For every action, there is an equal and opposite reaction.
Correct. Action and reaction. Okay, action and reaction. That's the third Newton law. So if there is an action, there will be a reaction force exactly the same magnitude but opposite direction. Okay, so these three things, it will be there in sorry, not the three, the first And the third one, it will be there in our statics analysis. Okay, in our statics analysis. Okay, any question about this, guys? Any question about this?
I'm still good, Pak.
Yep.
Not yet so far, sir.
Okay. Now, if there is no question about that, instead of me giving you a question, sorry, you giving you asking me a question, then I will ask you a question. Okay. So I okay. Now, if I have a box that have a mass of 10 kilogram, we assume that the gravity is 10 meter per second square. Okay. The box, I put the box on top of the ground. Okay. I'm asking a simple question first. Okay. Now, my question is, can you tell me what are the forces which is happening on the box?
I can, Pak.
So there's going to be
There's normal force and wave force to the surface. To the surface, there will be m times a, and there will be normal force to the upside, which is the opposite.
Wait. Okay. Sorry. Okay. Hey, why suddenly? Hey, why suddenly my sharing stop? My sharing screen stopped. Oh no,
No, it's still
Still
there,
here,
sir.
sir.
still there.
No, sir.
Okay. I remove pin. Okay. Remove pin and remove pin. Okay. The sharing screen still there. Are you sure? Why I can't see it in my presentation? Stop share. Okay, I think I will share again. Screen. Stop now. Okay. So, I think you can use the annotation. Just now, who answered the question just now?
Me, sir.
If this is the box, can you do? Can you use annotation feature in Zoom? If this is the box, please help me to draw the forces which is happening, forces and magnitude as well, with the direction and the magnitude which is happening to this particular box.
How to do that, sir?
Yeah, just use the annotation.
Where is it?
There's no
Annotation is,
box, sir.
I think annotation is on the top, right? I think this screen. View option. If you see,
No, there is no annotation.
No,
Yeah, it's unavailable, sir.
unavailable. Wait a minute.
Yes.
Why is that? Oh, because I'm sharing something.
Or I think you haven't cleared the permission.
Okay, quickly. How to do that? Share screen. Wait. Multiple personal. Okay. How to do that? I think I need. Oh, seems like because I'm presenting, you can do the annotation. I believe you can. How to do that? I'm not so sure about it. Okay. But anyway, yeah, it's okay. So can you guide me to draw the forces which is happening into the box?
Yes.
You said wait, right? Where I supposed to put it?
Wave force down arrow to the surface, which equal
Down
F.
arrow to the surface. Are you sure about it?
Wait.
The gravity, okay, and the weight, the force due to the weight, the accurate one, is not supposed to be at the bottom. Where
I mean from the center of the body.
Center of the body. Actually, it's not center of the body, but it's supposed to be from the center of gravity. If the center of gravity is at the center of the body, then yes. Okay. Then yes, you can put it from the center of the body. We just assume that this is the center of gravity. Okay.
Yes.
Okay. Then okay. Then the force is supposed to be like this, from the center of gravity. And what is the magnitude?
F equal to mass times G.
Okay, so it's supposed to be 10 multiplied by 10, okay?
Yeah, so it's 100 Newton.
100 Newton. What else is supposed to be there?
There's a normal force.
Normal force. Where I supposed to put it?
Same from the center of gravity, but it is the opposite of the wave force. So it's.
Are you sure? Normal force is happening from which surface to which part?
Maybe from the surface of the.
Oh yeah. From the wherever is the body. I mean, in Indonesian, nempel to its surface.
The body in which force is exerted.
It's supposed to be like this, okay? So
yes.
It's supposed to be happening at this particular point. So the center of the contact. Okay, normally we put it at the center of the contact. So if the center of the contact is in the middle, if the center of the contact is in the middle like this, okay, so we put it at the center of the contact like this, and it's supposed to be upwards, right?
Yes.
And what is the force?
Normal force.
Yeah, normal force. And what is the what is the value?
10 Newton. 100 Newton.
100 Newton. But actually, we cannot just answer like that. Oh, the value is 100 Newton. It's supposed to be following this sigma Fy equal to 0. Okay, so the total force, because all the things are in the static condition, right? So the total force happening there is supposed to be equal to 0. Okay, that's why the sigma F is supposed to be equal to 0. That's why if I put it in equation, 100 Newton minus normal force is supposed to be equal to 0. That's why we can get that the normal force is 100 Newton. Okay, I'm telling you to answer it step by step because this is the correct way to do. If you didn't do it this way, later if you make a mistakes at the end, the lecturer will not grade the process properly. So in order for you to get a good grade, okay, it is better for you to do it step by step. All the steps you have to put it there. Okay, write down all the steps. Then, oh, the lecturer will know. Oh, the step is like this. Then, if you make mistakes at the end, okay, then until this point it's still correct. So I will give a like 80% grade, something like that. You get it? guys, because this is the difference of 80% weight and 20% weight. Okay, if your answer is completely correct, then there is no problem. But most of the time, students may mistaken me. So the answer is wrong. But in order for us to know the process, you have to do it that way. Okay. This is my tips for you to answer the correct way. Okay.
Okay, sir.
Okay, sir.
Okay, good. And then about moment. Okay. Have anyone here studied what is moment?
Is it like torque, sir?
Something like that. But I believe you have learned about it. Right? Moment. Not yet.
I think we have.
Why you are not so sure about that?
Is it
You're
the
supposed to
MR
be
squared?
completely sure. Yes, sir. I know about it.
Is it
This
the
is-
MR squared, sir?
Huh? What?
Is it the MR squared?
MR square? No, that's mass moment of inertia.
Is it force times distance, sir?
Yes, correct. Force
Oh,
times
okay.
distance.
I
That's
know it
what we-
as torque. That's why I'm
okay,
more
okay,
familiar with it.
Actually, the general terms is supposed to be moment. Okay, torque is actually one of the moment. Moment in a particular direction, in one of the direction, one direction. So in a 3D space, we have 3 different moments. Depends on the direction. Moment in the x direction, y direction, z direction. Okay, so if we draw a 3D space, right, like this. Okay, this is x, this is y, this is z. 3D. This is 3-dimensional. Okay, then we have 3 forces: x, y, z. So forces we can differentiate forces in 3 directions: f x, fy, fz. Okay. Then moment as well, we can differentiate it in the 3 directions: mx, my, and mz. And just for one particular case, we call it as a torque. But I will not be discussing it today because it will be the topics of our discussion. Maybe talk maybe is next semester. What is the effect of torque in the body of the structure, like that, in mechanics of materials? But for this semester, we will not talk about torque. We talk about we assume that all the moment, we assume that everything we call it as a moment. Okay. So now I'm asking you guys, if I have this one reference point, that red dot on top, this one, then I have a force like this. Why I cannot wipe it down? I have a force like. Okay, for example, the force is 10 Newton. The distance here, is 2 meters, for example. If I'm asking you guys, what is the magnitude of the moment which is caused by force 10 Newton at point A? What is your answer?
20 Newton meters, sir.
20 Newton meters. So just now it's just simply like this, right? Moment is equal to distance, 2 meter, multiplied by the force, 10 Newton. So it's equal to what's wrong with this? Sorry, I'm not sure about this. Here it is. This is wait a minute. Camera screen up now. Then this. Okay. So just now we are talking about this 20. We get 20 Newton meters from the moment is supposed to be equal to the just now 2 meters multiplied by 10 Newton. That's why we get 20 Newton meters. That's what we call with moment. Okay. Anyone still having a problem with moment? Yeah. Or do you guys understand completely about moment?
May I see the diagram again? The one you put in the last slide for this calculation?
Diagram, you mean? Oh, okay. So the point, right? Okay, this one is a point A. Then this one is the force. Force is 10 Newton. The distance here is 2 meters. Okay, so the question just now is force which is happening. Sorry, I want you to calculate the moment which is happening. Moment at point A due to force 10 Newton force. Sorry, 10 Newton force. So that's the way to answer it. Okay, so that's the concept of moment. If we are talking about a vector, okay, if we are talking about vectors, okay, the moment is equal to the r here. R here is actually the vector, distance vectors, which is connecting from point A to the force. From point A to the force. Okay, from point A to the force. So vector r is actually the distance vector which is connecting from point A to force 10 Newton. 10 Newton force. Okay. Cross F, where F here is the vector, the force vector. So the 10 Newton force. So if we are talking about vectors, this is the way to represent moment. But if you just want to calculate using scalar, you can just do it like that. M is equal to the distance multiplied by the force. Okay, do you get it, guys?
Yes, sir.
Okay, if we are talking about the vectors, okay, now I'm talking about the vectors first. Okay, can anyone here help me to represent the 10 Newton force here with in the vector form? So the coordinates that we will be using is like this. This is x, this is y. I want you to help me to represent the 10 Newton force here into vector form, its vector form. So I can get the value and the magnitude of vector f. Anyone here? Nope. One?
So, sir, is the force supposed to go solely in the upward direction, or is that like an effect to the? So
Yes.
the
So
net
you're
the
supposed
net
to
force is
put
upwards.
the vectors. So you're supposed to change the form of that particular vectors, 10 Newton vectors, 10 Newton force into its vector form. So the value is 10 Newton, right? Do you understand what is vector, Asya?
Or is it like the matrix form? Is it like the parenthesis?
No, not matrix form, but in the
Is it
in
like
the vector form.
IJK, sir?
Yes, correct, like that.
Okay.
It's in its unit vectors,
Oh,
because
then
that's the normal way we represent the vectors, right?
is it 10J, sir?
10J, correct, 10J. 10 Newton J, like this. So that's the force, right? Now, I'm asking you again, how about R? The distance vector.
To meter I.
Negative 2i, negative 2i, 2 centimeters I, negative 2 meters I.
Okay, let's try to make it into a debate, right? 2 meter I or negative, 2 meters, not 20 meters. Negative 2 meters I. Which one is the correct one?
Negative, sir.
The negatives.
Negative, sir.
Why negative?
Because it's going to the left.
Actually, it depends on kesepakatan, but
No. It's not depends on the kesepakatan. It's not depends. It's not depends on our agreement. There is a strict definition on that. I'm checking you guys whether you know the definition.
I think because it is clockwise.
Not because it's clockwise, but it's because of whether you know the definition of that. The definition of
It's
is
negative
the
because
definition.
it's a direction. It's the vector has to have is defined by the
yes.
direction, right?
R here, because it's a distance vector, it's a vector which represents the distance from, remember, please listen to me carefully, from the point, okay, the center of rotation, from the center of rotation, which is A at this particular things, okay, to the force. So the vector, the distance vector is supposed to be from A to the force. In that case, it's supposed to be 2 meters or minus 2 meters I. 2 meters I or minus 2 meters I.
So it's positive, yes, sir.
I think positive.
Then
Positive,
it's
sir,
positive
positive.
then.
Positive.
Positive. The
Positive.
difference is, okay, if it is from the force to the point, the direction vector, the distance vector is like this, right? From right to left. But if it's from the point to the force, the direction vector is supposed to be like this, right? From left to right. Correct or not? It's a matter of positive and negative. Going to the right, because x positive is to the right, then it's positive. Going to the left, because x positive to the right is negative. Sorry, yeah, going to the left here is negative. Going to the right is positive. So it's a matter of positive and negative. But it's important because it's definition. So don't change the definition. That's why it's because it's important. And sometimes, like it or not, we have to use vectors. Okay. I'm sorry, there is a flash sale there as well. Okay, because I'm using my wife's tablet. So just ignore that part. Okay. Okay. Do you get it or not? It's a matter of definition. So that's why I try to highlight it today because it's important. Let's return back. Listen to me again. So it's from the center of rotation to the force. So that's the vector. From the center of rotation to the force. So it's supposed to be 2 meters I or minus 2 meters I.
2 meter I.
2 meters I. Yes, correct. We're supposed to use this one. Remember, from the center of rotation to the force. And one more thing, you cannot replace this. So you have to use that sequence. So moment is supposed to be R cross F instead of F cross R. This is completely wrong. Never use that. If the sequence is different, your positive and negative will be the opposites. Never use that one. So the correct one is this one. R cross F. R cross F. Okay, and don't try to remember about the correct direction of R. Don't use the opposite direction because the positive negative will be completely wrong as well. You get it, guys? Please
Yes,
answer
sir.
me.
Yes, sir.
Yes, sir.
So
Yes, sir.
the if we calculate it here, this one is M. Sorry, yeah. This one is M is equal to R. R here is 2 meters. I plus F here is 10 Newton J. So the results is supposed to be 2I cross 10J. What is the results there? What is the results there? Do you still remember the cross product? Hi guys, I'm asking you.
20 Newton meters.
20 Newton meters, and what is the direction? We are talking about cross product. Cross product is a vector multiplied by vector, cross with vector, and the result will be a vector. Okay, and dot product, if it's dot product, is vector multiplying dot with vector, the result is scalar. Okay, scalar. But this one, the result is vector, so there must be a direction there. Have you guys learned about cross product? I believe so.
Is it 20K?
Yes, correct. But no, I'm asking you guys. all of you, have you learned about cross product?
Yeah, we learn it in
Yes,
the
we
first
learned
semester
it
in the
in-
first week.
Then you're supposed to be able to answer it then. Why no one is answering me?
Forgot, sir.
Yeah.
Forgot?
It's been a long time.
What?
Yes,
It's
sir.
been a long time. One semester is a long time. What?
But it's not a long time, but in the holiday, I don't really open my book. So
Me
But
too,
still,
sir.
it's
Sorry.
yeah, no, it's a must-have skill, but yeah.
I'm telling you, okay. In order for you to survive in IDB, all the things it will be connected to each other. Okay. So statics here, you cannot forget it because next semester you will learn about mechanics of materials. Mechanics of materials, you cannot forget it because it will be connected to the next subject. And everything will be like that. So please, whenever you learn about something, don't forget it because it will be connected to the next one. Okay? Please remember that. That's your it is a tips for you guys in order to survive in IDB. Okay? So it's a cross product. Remember, I cross chain, the result is K positive. Okay, so I will not repeat all the things that the mathematics lecturer already told you guys because that's your job to review that. Okay, so I cross chain is supposed to be K. So the results here is supposed to be 20 Newton meter. The direction is K. Okay, so this is the results.
Okay, Pak.
Okay, sir.
Okay, so this is the way to handle it in a vector form. But most of the time, it will be enough for us to just calculating everything in the scalar form like this. But it's not necessarily you can forget about the vector form because sometimes, especially if when we handle three-dimensional case, you have to do a vector form. Okay, that's why please remember about this. Okay. Any question about this, guys? Any question?
So far, not yet, sir.
No, sir.
Okay, good. Then stop share. I will be using two devices here. I'm using Pak Ferianto's slide here. Okay. Why I wrote so wait a minute. Copy. Okay. So this is about vectors. Because actually for statics class, right, normally I don't use slides. So I just use slides for a problem example. But unfortunately for us, because the class is a online class, so like it or not, I have to use slides, and I will use my wife's tablet or my computers to explain about things whenever I need this to write something down. Okay, then I will share again. Oh yeah, one more thing. Don't forget to mark your attendance. Okay, mark your attendance in the academic.itb.ac.id. Okay, ac.id. This one. Can you see it, guys? This one.
Yes, sir.
Yes, sir.
Yeah. So this is the things that I explained to you just now. In order for us to calculate for the moment, there are two ways. in vector form, you can use this. Wait a minute, I select this. This one. Pen. Okay, pen. Yeah, you can use this in vector form. But if you just want to use a scalar form, you can use this. Okay. The force multiplied by the distance. Remember, the distance in the scalar form is the perpendicular distance. Okay. So here, remember, the d here is perpendicular distance. So F multiplied by the perpendicular distance, it will be the moment. Okay. Or you can use, in this case, is supposed to be this one, okay? The distance from point A to this particular point is this one, small a. Okay, small a. Then after that, the angle between, this angle is alpha. If this angle is alpha, okay, in order to get d here, we can use a here multiplied by sin alpha. Okay, so the basic concept is, actually you don't have to remember about this equation. What you have to remember is about this. But remember, d here, d is a perpendicular distance. So you cannot use distance like this, which is not perpendicular. The definition of perpendicular is force. For a force, right? You can draw a line like this for a force, which we call it as the line of action of the force. And the force itself, you can replace it anywhere whenever it's still in the line of action. Okay, so you cannot move it parallelly, but you can move it in the line of action, in the same line as the force. So for example, this is the line, this is the force. If you want to move it here, you still can, because it's still in the same line of action. If you want to move it here, you still can, because it's still in the same line of action. But you cannot move it here, because it's different line of action. Okay, you cannot move it here freely like that. But you can move it in the same line of action, okay, freely. Then in order to calculate moment, you have to multiply the force with the perpendicular distance. The perpendicular distance here means perpendicular to the line of action. Do you get it, guys? Hello, hello.
It's clear for me, sir.
I need your feedback. So
can there be a case where is there like
Asep? Okay.
could there be a case where R equals D?
Yes, of course. R equal to D. There is a case like that. Wait. Let me annotate here. How can I note it here more? Why I cannot annotate here? There is a problem. Okay. There is a case like that. Okay, I will try to draw it here just by using this. Okay, for example, the point A is like this. Then, I just use this the same particular graph. Okay, then I will be deleting this. There is no force F here. Okay, the force I put it here. Sorry. The force, I put it here. Okay. In that case, here, the definition of R is the place, the distance vectors from point A to the point of the vector, okay? The line of action, sorry, the point where the vectors works, okay? So this is the point where the vectors work. Okay, so R here will be from here to here. This is our R. So R here is, there is no more. And in this case is R, that R is the same as the D. Okay, so although R is a vector, okay, D here will be the magnitude of R. Okay, R here, so D here will be the magnitude of R. So in this case, it's the same. Okay, and just now, the magnitude of A here, which in the previous case, okay, A here is actually the magnitude of previous R, remember, previous. So in this case, it's the same. D is the same as A. Do you get it, Azar?
Okay, sir.
You sure?
Yes.
Okay, good. Okay, any question about this? Because this one is a important topics. And after the theorem of Fagnon, and after that we are talking about couple. But after that we will be having several problem example. But my focus today is just the definition of moment. Any question about this? So actually, in order for you to not make it difficult, okay, whenever we have a force like this and center of rotation like this is center of rotation, this is the force. Okay, the moment which is caused by the force to the point, for example, in this case is point B, okay, is the distance vector, in this case is R, cross the F, always like that. So the moment is supposed to be equal to R cross like this in the moment form. But sometimes it is enough for us to represent it in the a scalar form. In this case, it's just because it's scalar, it's okay for you to put it in the opposites. You can swap D and F. So in scalar form, it's supposed to be okay. So in the scalar form, is D multiplied by F, or F multiplied by D. It's the same. But in the vector form, you cannot change the sequence. Where D here is the perpendicular distance from the point to the force. Okay, I think I want to check your understanding, guys. Okay, let's see. partisipan. Okay. Sunita, you. Hello, Sunita.
Yes, sir.
Do you understand, Sunita?
A little bit. I don't really understand, sir.
Oh, which? Okay. Okay, next time I cannot accept like this, okay, Sunita? Whenever you don't
Okay, sir.
understand, ask me directly. Which part you don't understand? Because
Okay, sir.
I want to make sure that all students in my class can catch up with everything that I told you guys. Which part that you don't
Okay,
understand?
So sir, I want to ask.
No, not you first.
Oh,
I'm asking Sunita first, one by one. Sunita, which part you don't understand?
I wanna ask what is the what's the M? What is the M?
M here is moment.
For? Oh, it's moment.
Moment is if previously you learned about talk, okay? Yeah, it's just the same as talk.
Oh,
Torsi.
okay.
In bahasa we call it torsi. In
Yeah.
bahasa as well we call it as moment. So it can be moment, it can be torsi. It's more or less the same, but the definition is the same. Okay.
Okay, sir. Yes, I get it. So it's just like the torsi in basic physics.
Yeah, in physics the same. So remember, right? In first Newton law, we call it we have in the first Newton law is F is equal to mass multiplied by acceleration, right? Sunita?
Yes.
But in the same way as well, in the rotational movement, okay, in the rotational things, we have torque or moment, okay, torque or moment equal to inertia, mass moment of inertia, multiplied by angular acceleration. Do you remember, guys?
Okay. Yes, I remember.
Yeah, it's just the same. So this one, right? Moment is equal to mass moment of inertia multiplied by alpha. Alpha here is the angular acceleration. Then in the translational, we have this. F equal to mass multiplied by A. So the definition is the same. That's moment. But do you get my explanation about how to find a moment, Sunita?
Yes, sir, I get it.
Okay, good. Then just now, I believe just now somebody asked me, right? Who was that just
yes, sir, me.
Okay. So what is the question?
I want to ask. So, the one that we should times in. I mean, if there's an angle like that, it's not the F but the R. Yeah.
Sorry, I don't get your question. If there is an angle, yes.
I mean, in the picture there is an alpha angle, right?
Okay.
So, the one that we have to make it perpendicular is the R, not the F. I mean,
yes, correct.
Yes, like that.
Yeah, the R. So actually, it's not the R, but perpendicular direction. Perpendicular distance. We call it as D. D is the perpendicular distance.
Oh, D. Okay.
Yeah, so that's why in the scalar form, in order for us to calculate the moment, it's like this. Moment is equal to D multiplied by F, where D there is the perpendicular distance.
Oh, I see.
Okay, remember that if we have a force F, okay, if we have a force F, okay, you can move it anywhere as long as it's still, you can move it anywhere freely, as long as it's still in the line of action. That's the way it is. So wait a minute. I think I will try to in order to explain it better.
Sir, what is the line of action?
Yeah. That's why I want to explain it again. So new slide. Yeah, this one is line of action like this. Wait a minute, just now. Then okay. For example, I have a force like this. Sorry, not like that. Just this one, okay? I have a force like this. This is a force, F. Okay? The line of action is the line where the force is working. So actually, it's just like this. It's just like the extension or extension line of the force itself. You get it? Hello? Just now, who's asking me? Hello?
It was Zik. So
Me, sir.
Yeah, do you get it or not? Say.
Can you reiterate it again, sir?
Yeah, so is line of action is actually it's just like the extension of the force. So remember, the force here, it has, this is the force, right? This is the force.
Yes.
Okay? Yeah, the force, it has a the direction, right?
Yeah.
In the same direction of the force, you can extend a line like this, right? Okay, on the top right and the bottom left. It's actually just extension of the force.
So
a line which is extended, which actually extension of the force.
Yes.
Okay, then we know that this is the line of action. Actually, you can just move the force without changing the magnitude anywhere, as long as it's still in the line of action, and it will not change anything. It will not change any results. So you can delete this and replace that one with the same force, the same magnitude of force here. And the name is still the same, F, like that.
I see, sir. Okay.
But replacing, not doubling, okay? It's different.
Yes, sir. Yes.
Yeah. If it's doubling, means that you calculate it double. It's replacing. So you delete the first one, replace it with the new one. As long as it's still in the same line of action.
But sir, would that change the moment?
It won't. It will not change the moment.
Why not, sir?
Exactly the same. So for example, I want to change. I want to calculate the force of the moment of force F to this particular point A. Okay. What is the equation just now in order to calculate the moment? Vector form.
R cross F.
R cross F. Okay. This one is, the F is the same. So for example, this one is R. So this is the R1, right? Yeah. This is R1. And this is supposed to be R2, right? Okay. If you try by yourself, you will find out that R1 cross F, yeah, the result will be exactly the same as R2 cross F. You can try it by yourself, but I guarantee that the results will be the same.
So if in this case, that means the distance does not affect the I mean the position
No,
of the
the
F.
distance is affecting the distance will be affecting it. The perpendicular distance will be affecting it. The distance, only the distance will not be affecting it, because actually the magnitude here, the magnitude of both, which is equal to the magnitude of the moment, okay? The magnitude of the moment, yeah, it will be the same as d perpendicular distance. Remember, right? This is a scalar form, right? Because I'm talking about magnitude of the moment. So d multiplied by what? F, right? Correct or not? Just now, when we talk about the scalar form, is m equal to d multiplied by f, right? This one. Correct, right? See?
Yes, sir.
Answer me,
Yes.
yeah.
Yes.
Okay. So don't turn off your mic. You have to keep answering.
Oh,
Okay.
okay, sir.
So remember what? So the magnitude of this moment is d multiplied by f, right?
Yes.
In the scalar form. What is d?
D is the distance, right?
Perpendicular distance.
perpendicular
Don't forget about that.
Oh yeah, because it's in vector form. Yeah.
Okay. Perpendicular distance. Okay. This one is not anyway, if you want to calculate the moment, okay, you have to use d. D is always perpendicular. So whenever you use this form, scalar form, m equal to d multiplied by f, d is always perpendicular distance. Always perpendicular distance. But if you use a vector form, yeah, r, it can be anywhere. But the result will be the same. Why? Because the magnitude is the same as d multiplied by f, actually.
Yes.
D here, it will be the perpendicular distance here.
Yes.
Perpendicular distance is from the center of rotation to the line of action of the force.
So that won't change. So the position.
It won't change. That's why. So even though the force is here, and the center of rotation is here, in order for you to calculate using scalar form, you have to draw the line of action first to find for the perpendicular distance, because the perpendicular distance will be here, right?
Yes. And
So you can just write down that this is d. No, this is not d. The d is here, perpendicular distance. Always perpendicular distance. You get it, see?
Yes.
So the results of this
will always be the same.
Will be the same as this one.
Yeah. I see, sir. Understood.
Okay. So you can move the force anywhere you want. It's up to you, as long as it's in the line of action. If it's not in the line of action, you can move it, but there will be a consequence. And we will discuss about that tomorrow.
Amazing, sir. Amazing. Thank you.
Amazing. Why it's amazing? It's not amazing. Okay, before I close the class, because the time is almost up. Anyone want to ask question? Johan Samuel, you get it, Johan?
Yes, sir. I get it.
You sure?
Yeah.
Okay.
Professor?
Yep.
I have a brief question for the vectors. In the previous question, the force we used J and the R we used I. Does it always have to be those vector J?
If you are not comfortable asking question in English, and you are more comfortable asking question in Bahasa, it's okay as well.
Okay, it's okay. I'll try using English.
Okay. What is your question again?
For the force direction IJK, when we assigning the for example force or force F vector or R vector, are we free to use any of the I, J, or K, or does it have to be between here. Wait, can I annotate? Can I annotate, sir?
Yes, of course.
Okay, so in the
Can you?
previous, so in the previous question,
Okay, good.
uh,
Why some of you can annotate and some of you can't?
That's not cannot,
previously
sir.
I couldn't. Previously I couldn't. It
Uh,
was
now
available
can
just
Then
now.
you
Yeah.
already
cannot.
I
Because you said
see.
it
So
was
most
separate.
likely, if I wrote something in the tablet, you can't do that. But if I
Mhm.
do it in my computer, you can do it. Okay.
Yes,
The
I think.
setting, sir, setting.
Yes, sir. That's the
So
case.
the problem is in the setting of the tablet then. Okay.
Yes,
So
something.
continue with your question.
So the previous question, it was something like this, right? 10 newtons, and then this is 2, and then for, was it F, I think? For R, it was 2I. Wait, I, and then for, what was the
10J.
other one? Yeah,
10J.
10J. F equals 10J. Now my question is, do we have to use 10J or can we use 10K, for example?
Yeah, it depends on the direction, of course.
Okay, in the previous question.
Everything depends on your first assumption. So you have to assume what is, because sometimes the coordinate is not given, right? The coordinate is not given. For that particular case, in the problem like that, you have to define the coordinate. But coordinate, it cannot be, the coordinate is, you have to do it properly, especially in 3-dimensional. For 2-dimensional, just simple. Just put it in X and Y, right?
Yep.
So always like this. This one is X, this one is Y. 2-dimensional case is as simple as that. This is the standard one that we normally use. But 3-dimensional, you have to do it properly. Okay. For example, if you do it 3-dimensional, this one can be X, this one can be Y, this one can be C. But there is a big but there. Okay, you cannot put it like this. This is C, this is Y, this is X. Does it make you confused?
Yes.
Okay, because you have to follow, for 3-dimensional case, you have to follow the right-hand rules. So can you see my video?
Yeah.
If X is in this direction, my this forefinger, okay, this forefinger is X direction, okay. Then if Y is in this direction, like this, okay, then your C will following your thumb.
Okay.
So X, Y, C. That's why just now I can write like this. I replace it again, okay. This one. So this one, it can be X. This is the standard one. X, Y, C. Because in this case, I keep up. I follow the right hand rules. Right? X, Y, C.
Okay.
So you have to follow X, Y, C using right hand rules. But for 2-dimensional, directly use this one.
Okay. I think I understand. Thank you.
So after you define that, then the unit vectors, you have to follow that. Remember, okay? The unit vectors, you have to follow that. That's all. That's simple. Any other questions? Maybe the last question? Before I stop the class?
Sir,
Who's this?
we will play around 3D instead of 2D.
Matthew. Yeah. What is the question again?
Will we learn in 3D instead of 2D?
Very limited case. So most of the time it will be 2-dimensional because sometimes it's just too complicated to learn about 3D. But I will still teach you about 3D Okay, I will still teach you about 3D. Most of the time, the problem that we will learn is just in two-dimensional.
I think 2D is best, sir.
But you see, okay, the everyday problem is in three-dimensional, so you have to know about that. Okay.
Okay, sir.
Okay. Okay. Any other question? I think I will ask again one more students. Okay. Florencia.
Yes, sir.
Do you get it, Florencia? All the things that I told you today.
Yes, sir.
You sure?
80%.
80% is not sure then. What is the 20%?
Maybe for determining the direction in the three-dimensional.
In the three-dimensional. Oh, the last one, you mean?
Yes, sir.
Oh, you mean the XYZ, right?
Yeah, for the Z one.
I will read it again. Whenever we have a problem, so maybe later in the problem example, I will explain what. The first thing that you're supposed to do is to determine the coordinates. Okay, you have to determine the coordinates. So in two-dimensional, it's very simple. Directly use this x to the right, y up, going up. Okay, but in three-dimensional, you have to use right-hand rules. Like that, x, y, z. Like that, it's supposed to be following the right-hand rules. If x is, you're supposed to see my video, right? Hello?
Sir, yes.
You can see, right? If x is following this, my 4 fingers, okay, this direction, then y is 90 degrees from that, like this. Then C is supposed to be following your thumb's direction.
Oh, okay. Thank you, sir.
Okay. I think it's supposed to be enough for today. Okay. If you still have any question about this, please remind me tomorrow to discuss about that at the beginning of the class before I continue with moment and couple discussion. Okay.
Okay, sir. Thank you.
Okay then. I think that's all for today. I will try my best to upload the video as soon as I can. Okay, and then I will post the link of the video or the channel in the group, so you can check it by yourself whenever the class ended. You can check whether I already uploaded or not. If not, then better for you to remind me. Okay, I think that's all for today. See you guys tomorrow morning. Okay, remember tomorrow morning is 7 a.m. So please try to wake up early tomorrow morning. Okay, see you guys tomorrow.
Okay, sir. Thank you.
Okay,
Bye
sir.
bye.
Very
Thank
much,
you,
sir.
Okay,
Yep.
thank you, sir.
Thank you, sir.
Thank you, sir.
Yep.
Thank
Okay,
you,
okay. See you.
Thank you, sir.
Thank you, sir.
So,
Thank you, sir.
okay, okay. Bye bye.